Greetings, Earthlings. Well, you've seen the video on the Fluke 8060A, or if you haven't, it's certainly out there for you to see. Today we're going to look at the Fluke 8050A, which is a benchtop version. I won't say it's really a version of the 8060A. It predates the 8060A and has slightly different feature set. But like the 8060A, it measures voltage, current, and resistance. 200 microamps, 200 millivolts, 200 ohms, minimum range, up to, well, let's see, it's got a 20 meg ohm range, up to 1,000 volts DC, 2,000 microamps or 2 amps, and 20 meg ohms, as I said. Now, there are two versions of the 8050, and it's something you probably want to watch out for if you're looking to buy one. They're obsolete. I mean, they're discontinued. They're no longer available, but you can find them used, and they still are fairly decent. It's 4.5 digits, which is pretty good. Adequate for most of my needs. So as a secondary reference, I wouldn't have this, especially since it's an old used device. They date to about 1980 or so, as my sole meter, the only one. But as a secondary reference, it's always good to have spares, extra meters for measuring different things. But there are two versions, as I said. And the biggest, easiest way to tell is that the one has this little battery charge light. So the two versions are, there's one that's runs solely off of AC power, and the other one that runs off of AC power or NiCad batteries. Now this one I got, and it was advertised as working, and it was not indicated as a battery version. That's option 01, by the way. And I got it, and it didn't work, and the batteries were dead. Let's see. Them are the batteries. Well, those are not original batteries. Those are replacements, but sub-C NiCads. And it won't work without the batteries. But wait, it's working. Yeah, well, okay, we'll get to that. So I did modify it. Found a couple of people online who had made mods to it to get it to run off of AC power only. I don't want the battery. I don't need the battery option, so I wanted AC only. There is an LM317 in the power supply for this, which is configured as a current source. And the basic change is to convert that to a voltage source. Some people have replaced it with a 7805. This guy, I think this might have been Mr. Modem Head, I don't remember, kept the original regulator and just made it put out 5 volts. But he cut some traces and on the PC board. And I wanted to do it without cutting traces so that it could be reversed if somewhere down the line somebody wanted to. So there's a couple of things here. There's a cut trace here, there's a cut trace here, and there's a jumper installed here. And that's the entire mod. Well, and then removing this resistor so that light doesn't come on and say it's charging the batteries. Whenever the power switch is off on the original one, that light will come on claiming it's charging the batteries, even if there's no batteries in it or whatever. Anyway, I figured by lifting the legs on a couple of components, and that's pin 1 of the 317 regulator and one leg of this R26. He has you replacing R26 with a 150 ohm resistor, cutting that trace, replacing R25 with a jumper, cutting this trace, installing a jumper here, and installing another resistor. Well, what I did is I lifted the leg of this, which is the equivalent of cutting that trace. I installed the jumper on the bottom of the board, leaving R25 in place. And then I connected a 150 ohm resistor in series with this one, lifted the leg pin 1 of the 317, which is the equivalent of cutting that trace, and then added that resistor. And so I was able to do it without cutting any traces. And so, you know, like I said, somewhere down the line, someone may choose to convert it back. And I've just made that easier. Okay, so let's have a look here. Oh, and looking at the 8060, the differences. This has a frequency measurement. It also has a, well, this does dB as well. What was the other thing on this? This can measure frequency. Oh, and it has the continuity tester, which this doesn't have. Okay. And it's battery powered, runs off a 9-volt battery. So that's great, I have that, you know. So I want this as a benchtop. So let's start by measuring, checking some voltages here. And we've got our reference over there, the Tektronix meter, which we'll compare it against. And we're going to start around 1.9 volts. And 1.905, 1.90576. I'll call that close enough. Let's go to 190 millivolts. How about? Let's see. Oops, I'm going the wrong way. Bear with us here, folks. Okay. And of course, it is manual ranging, yes. Whereas the Tektronix is auto ranging. 0.1908. Come on. 190.79. 190.82. Oops, okay. Yeah, that's pretty close. That's pretty close. Oh, was I not on the 2-volt range when I did 1.9? Let's put it back to 1.9 volts. Two-volt range. 9057, 905. Oh, okay, there you go. 4.5 digits. 59577. Yeah, that's pretty darn close. Okay. And we could go up to like 19 volts, I guess. Somewhere in that ballpark. 20-volt range. 19.832, 19.836. Okay. Pretty close. Pretty close. I might mention that, let's see, once I did the mod for the voltage regulator, I discovered that the processor chip, if you will, was bad in this, so I had to buy a parts unit and swap out processor chips. And then it was out of calibration, so I had to calibrate it. So I have calibrated against that a few days ago, and it was closer when I calibrated it, but now it's drifted a bit, I guess. Or it's a temperature thing, or I haven't let everything warm up properly. But anyway, I'm pretty happy with those readings. Let's look at resistance. Oh, before we do resistance, we'll talk about what to expect with this thing being as old as it is. You know, early 80s. The common ailments, as with all old equipment, include the electrolytic capacitors And the LCD display will go bad on these things as well. Now, there's a number of mods out there to replace that LCD with LEDs. And to that end, I have acquired some HP. These are amber. Let's see, 5082-7621. But then the overflow indicator is a let's see, that's 7621, that's a 7626. Those are a little harder to come by. And the reason I went with the vintage HPs rather than something brand spanking new is they don't seem to make these overflow indicators anymore. So there's the overflow indicator. This is from the parts unit. You can see that will, whoops, I said that will fit inside the bezel with some room left over for 3 additional indicators. It's got a dB indicator, high voltage indicator, and a relative indicator. There you can see rel on that one. So it's going to need 3 additional LEDs for that. But that's a separate project, and that will be a separate video if I ever get around to it. Okay, on to resistance. You know what? That's a bad idea. Okay, don't try this at home, kids. If you have a crappy meter, you'll blow it up doing what I just did there. Okay. We're done with that for now. Okay. Ooh, silence. Okay, so let's bring in our, bring in our 100 ohm reference here, so-called, which is not really 100 ohms anymore, if it ever was. It's like a 0.1 or 0.15% resistor dating from, I don't know, 1963 or thereabouts. So, you know what? That's a lie. I have to do a relative reading because of the probe, the lead resistance here. Okay. Let's cancel that out, and then we get 99.9, 91, whatever. Okay. Let's see what the Fluke thinks of it. Yeah. Okay. The clips come off. We learned this. We learned this last time. Oh. We did learn this in the last video. Clips cause problems. Okay. Well, let's see. We're going to be on the 200 ohm range. Let's get the lead resistance. This also has a relative. Yeah. There you go. So we'll zero that out. $99.9, I think that pretty much agrees with what the Tektronix said, so we're in good shape there. Okay. For some other fun resistance measurements, let's bring in the heavy artillery. Okay, here we go. This is just fun. Another bit of vintage fun here. And I should be able to, oh, you know what? That one's going to need a clip. Okay, This is a Leeds and Northrop 5305 test set, so-called test set. And it has precision. It's actually sort of multiple units in one. Precision resistor decade box right here. A galvanometer here, and then a precision divider here. And then it would have batteries, either internal or external. And this is what they used back in the day. Again, about 1963 vintage, for measuring resistance accurately. But if I just connect from here to here, then I'm just measuring the resistance of whatever this is set to. So again, I want to zero that out. I said 0. Let's see if I can get 0. Yeah, okay. And then I should be able to dial in any... oh, okay, I'll put it on the 20K range. Pretty much any one. Let's go 1, 2, 3, 4, and see how close we can get on that. Well, we're off by 1 count. Oh, gosh. How terrible. Anyway. 5, 5, 5, 5, 5, 5, 5, 5, 5, 5. There we go. 5, 5, 5. Right on up to 9. Oh, now we're at 4 again. So we're off by a couple of counts, but that's still actually within spec on this. This, I think, is claims 0.15% resistance. And the accuracy on this is, I don't remember offhand. I'll put it up on the screen, and then plus or minus, a count or two. Let's switch to current. And we'll bring out our current source. You see that? Is that in the picture? Well, it's in that picture. Okay. That's set to about 5 milliamps. And so what I'm going to do, I'm going to go from there to there, from here to here. So once again, DC current. Okay. And from here to here. Okay. Whatever it is, this is trying to put out about 5, but 4.94, yeah. We're off by, a couple of counts here, maybe. That's fine. On a lower current range, we're into the microamp range, 50 microamps, 50.86, 50.86. That's pretty close. Okay. So I'm pretty happy with that. Let's go to, 190 would be somewhere in that range. 196 point, yeah. We're in agreement. Okay. All right, and just for completeness, let's do an AC voltage test, something I neglected to do with the 8060A, but I don't do a lot of AC checking anyway. Got this guy here putting out, it's about 200 hertz, and we'll go to AC volts. And that says 1.9002. You can tell this isn't just a random output. I did fiddle with it. Over here we've got 1.9003 on the 2-volt scale. That's close enough. 4, 3, 4. Close enough for my purposes. Crank that all the way up. See what we get. 10.7685 on the Tektronix. 10.7685. 773 here. Marginal. Go down into the millivolt range. Let's see. AC was 200 millivolts, yeah. Okay, let's see. 52.379, 52.41. Yeah, call that good enough. Get it up around 100. See what we see. $100.719, 100.75. Well, it's not great, but it's close enough for my purposes.